I'm Mike, and I'm going to be talking about some additive manufacturing applications with polymers for different things in the medical field. And the first company I'm talking about is Materialize, based out of Leuven, Belgium. 5 to 1,000 employees. Uh, Basically, they do rapid prototyping. On their website, I guess you can email them your file for whatever parts you want. That's something they make there, and they print them. But their bigger stuff that they're getting into is software, and mainly for biomedical engineering. So the part that was made is a tracheal splint. Your trachea is like your windpipe, right? Um, what this is for a kid who has a collapsed windpipe. They take that little splint and they put it around the windpipe and it pops it open. Um, it's made out of polycaprolactone, which is a bioabsorbable polymer, and Materialize provided the software to do it. Basically, they would take the CT scan and convert that into the file to base the printing off of, and it was printed with SLS at University of Michigan. And so that's the kid that they stuck it in. His name's Kaiba, and from somewhere in Michigan. So these collapsed tracheas are actually fairly common. About 1 in 2,000 children have it, and I guess most of them improve on their own by 2 or 3. The trachea will just naturally grow a little bit stronger and stop being collapsed from whatever genetic defect that is. But like this kid, some of them are so severe that they don't have time to improve. So odds are he would have died without it. So the reason that this works so well is that it's a custom fit. And I was just thinking about this earlier. It's also a really small part. So if you can imagine like the kid's probably still growing when he's on a ventilator. So even if you do just take an image of it and it takes a couple weeks to build, I wonder how well that's actually still going to fit. Basically, if you would have molded it, it would have been a long lead time, and the kid probably would have died without it. So the next one is actually a hospital, and that's the little girl, not the older girl. She's the one that they actually did this on. The hospital that they did is St. Thomas Hospital. It's in London, England. I don't know how big it is as far as people, but most hospitals you measure in bed size, so it's 1,100 beds, which is pretty big. And it's also a teaching hospital, so they do a lot of kind of newer stuff, kind of cutting edge things. This is actually a couple of years old, and it's way more common now, but what it did is it made a model of her heart. That girl on the front page had a hole in it, and basically the doctors weren't quite sure how to repair the hole. So by having a model and physically be able to hold it, they can see how they could design the patch and go inside there and actually sew a patch over this hole without damaging the heart more. So the one they made here was with SLA. And like I said, it's getting more common now, so there's other ones I've seen out there that they're using FDM for. Basically, you can do any kind of AM process to model the heart. And the reason why it's beneficial is that infant hearts are really difficult to operate on. They're tiny. You have holes in. If you have a hole in it like she did, it's hard to figure out where it is and physically get the patch over it without getting prepared for it. So having that model allows you to get better prepared. So it reduces time in surgery, which helps improve survival rates. And for this, the doctors estimated that it would be a relatively normal life expectancy, and they were saying that before similar surgeries, you would only expect 20 to 30 years, which I'm not sure quite how you quantify that, since you've only been doing it for a couple of years, and you can really say it's going to be normal. But I think the doctors probably know a little bit, I guess, if it's an easier surgery or not. And they're also doing this with or modeling different body parts with for skeletal surgeries, for like soldiers who've lost limbs. Like soldiers who lost limbs, I think some of them are more for like putting hips back together or rebuilding hips. And so one of the doctors was quoted in there as saying that, if you did a traditional model of this, it would be about as expensive as the surgery. So, just printing this part alone is relatively cheap and saves lives and makes life easier for everybody. So those are my references.